This is Algebra 1, Lesson 9, and we'll also look at Lesson 10. For Lesson 9, we are looking at algebraic expressions and being able to evaluate them based on the different variables and plugging in what we have. So let's jump right in. So the first thing that we need to know is what is an algebraic expression? And this basically is saying we have variables or numbers which use operations. So we could have a numeric expression that just has numbers in it, with addition, subtraction, multiplication, division, or with algebraic expressions, we have variables. So let's look at a couple examples. First, if we have 3x minus 4x plus ax, when x is 3 and a is 1, all this is saying is that if I replace x in our expression with 3 and replace a with 1, I could then evaluate this. So when we do this, all we see is taking 3 and replacing x with 3 minus 4 times 3 plus 1 times 3. And then we can just go through and simplify. So 3 times 3 is 9 minus 12 plus 3. And 9 minus 12 is negative 3 plus 3 is 0. So all this means is being able to plug in numbers for our variables. Let's look at a couple more challenging examples of this. All right, so now looking at ones that have exponents in them, same process, we just now need to make sure that we're following order of operations for sure. So let's plug in y as 2 and z as 4. So with that we see 3 times 4 minus 2 squared minus 4 times 2 cubed. So we start simplifying and we start with the parentheses, so we can do 4 minus 2 is 2. We're going to square that. And we can also continue writing down the expression. We can continue with the exponents to say 2 squared is 4, so we have 3 times 4. Minus 4 times 2 cubed. 2 cubed is 8, so we have 4 times 8. So 3 times 4 is 12, minus 32 is negative 20. Okay, and if you want to try the bottom one, the answer to that I believe is 246. So check your work when you're done if you want to try that bottom one. Okay. So we can also compare them, but really it's just the same thing. So really quickly, we can plug these in and say 3 times 4 squared plus 2 times 3 minus 4 times 3 cubed. And all we have to do is simplify. So I'm going to do the exponents. 4 squared is 16, so 3 times 16 plus 2 times 3 minus 4 times 3 cubed is 27. Okay, we can continue with that multiplication, and we see 3 times 16 is 48 plus 6 minus 4 times 27, let's see, that's 27 times 4, 8 is 108, I believe, minus 108. Okay, so we simplify and we get 54 minus 108, so we do 108 minus 54, and then our answer will have a negative on it. So we have 4, we get a negative 54 for this expression. Pretty small. All right, let's make some room for this next one. So let's try it. 2 times a squared times b squared. So we do 2 times 4 squared times 3 squared. So we do 2 times 16 times 9. So really we just have 32 times 9. We'll do that really quick. 32 times 9 is 18, 27, 28. So we have 288. Clearly the one on the right is greater. So we would say negative 54 is less than 288. all we have to do is plug in the values. Okay? Now, sometimes we see these algebraic expressions and we see them in word problems. So let's look at this one. A company charges $20 monthly fee and 45 cents per minute. The company uses the expression 20 plus 0.45 m to find the total amount of charge for each month. How much would the company charge for 200 minutes? Well, what's nice about this problem is it gives us the expression 20 plus 0.45 m. And it tells us how many minutes. M is going to equal 200. So if we plug this in, we're just going to do 20 plus 0.45 times 200. Okay, and if we do that, we should get $90 right here plus 20. So we get $110 during that month. Okay, pretty expensive, to be honest. So maybe you should find a company that doesn't charge 45 cents per minute. All right, let's try another one. So a company charges $50 a month and $4 per movie rented. How much will it cost for 7 movies if it's rented within the month? So with this one, it doesn't tell you an algebraic expression. We have to come up with them. And we know that if we have $4 per movie, that is going to be the part that has the variable. 4 times, well, we don't know how many movies are rented necessarily in a month, so we put it as a variable. How about M? That $50 per month, well, that just stays as $50 because that's a fee. That's something that you pay up front and then you pay $7 for every movie rented. So we would say 50 plus 4 times, well, in this case, our number of movies is 7. So we would do 4 times 7. Well, that's 50 plus 28, so we get $78 per month. Also pretty expensive. Okay, so with algebraic expressions, it all comes down to being able to plug in our variables with actual numbers. Now let's look at lesson number 10. This one is about adding and subtracting real numbers. So although it may seem simple, we're going to be looking at some more difficult ones that kind of challenge us as far as how do we work with these negatives, positives. So some vocabulary for this lesson: absolute value, we're talking about the distance away from 0. Sets and elements, a set is a collection of items and the elements are what's inside the set. Integers, we're just talking about all positive, negative, whole numbers, and that includes 0. Whole numbers, remember, are just our counting numbers plus 0. Remember some rules for adding and subtracting fractions. We must have common denominators to be able to do this. Without common denominators, we would have a really hard time adding up these fractions, and they definitely wouldn't come out anything standard if we don't use common denominators. So let's say we have 1/2 plus 2/3. Well, a common denominator for that would be 6. So I could multiply this one by 1, but I'm going to make it so that it actually helps me. So I do 3/3. And this one I'll multiply by 2/2. By doing that, I will get a common denominator of 6. So this one is going to be, I'll rewrite it over here so that it's 3/6 for my 1/2 plus 4/6 for my 2/3 to get a total of 7/6. That is only possible by doing common denominators. Now, rules for adding and subtracting decimals, remember we must line up the decimal places. So if we have 3.56 plus 4.11, we must line them up so that their place values are in the same spot. So we'll say that is 7, 6, and 7. So 7.67. Okay, let's look at some examples. Negative 1/5 plus 3/5 minus 2/5 minus a negative 4/5. What's nice about this is there are already common denominators, so we just need to work left to right, being able to combine these. So if we do negative 1/5 plus 3/5, our denominators are the same, so we can say that's a positive 2/5. And we will subtract 2/5 minus a negative 4/5. Okay, well, 2/5 minus 2/5, that's just 0. And then we're going to subtract a negative 4/5. Well, using our rules for subtraction, I can say, well, I am going to actually add the opposite of negative 4/5, which is a positive 4/5. And 0 plus 4/5 is just 4/5. Next, we look at these decimals. So when we look at these, we're still going to go left to right, lining up the decimals as we go. So the first one is 3.16 plus a negative 1.22. That's really just like subtracting 1.22 from 3.16. So we do 3.16 minus 1.22. We get 4. We're going to borrow from the 3. And we get 9 here and a 1. So is it going to be positive or negative? Well, in this case, it is going to be positive because we have a large 3.16 plus a smaller negative 1.22. Remember, when we're adding things, we can subtract the numbers and then take the sign of the greater absolute value. All right, so now we have 1.94 minus 4.73 plus 5.6. Okay, now let's do the 1.94 minus 4.73. Well, in this case, we have subtraction, so we can always take and add the opposite. So that we're doing 1.94 minus 4.73. Well, rules for addition say we are going to take and subtract these numbers. 4.73 minus 1.94. Okay, let's do that subtraction. Going to borrow some, borrow again, and we get our answer of 2.79. The question though is it positive or negative? And since this negative 4.73 is a greater absolute value, our 2.79 is going to be negative. So we have negative 2.79 plus 5.6. And lastly, we are going to once again add these numbers, but we'll subtract them and take the sign of the greater absolute value. So we do 5.6 minus 2.79. Add that 0 on the end. We're going to borrow some so that we get 1, borrow again, and we get 8, and then we get 2. And since that 5.6 has a greater absolute value, this is going to be a positive 2.81. All right. So even though it may seem simple adding and subtracting real numbers, it can get pretty complicated quite fast. All right, order these numbers from least to greatest. Well, when we look at this first set of numbers, we see we're always going to look for negatives first, and we see a negative 2. That's definitely going to be our smallest. Then we look and we see, all right, which one is closer to 0? And I'm going to put this as all different fractions. So 1.125 is going to be just 1/8 versus 1/2 versus 7/8. Well, this 1/2 is really 4/8. So it's pretty easy to compare them to say I have negative 2, 1/8, 4/8, and 7/8. Okay? And the next list you would put as negative 0.75, negative 1/4, 0, and then 3/5. All right. Another example of this is when we get into real life banking and we can see the difference between investments. So Carly invested $250 in 2 accounts. We can see the balance per quarter. Investment A after quarter 1 has $255. All the way up to quarter 4 has $262. Whereas investment B, we go from $260 to $290. So which investment grew more? Well, we can see that the $260 to $290, that's about a $30 difference. Even though we go down in this quarter, we still go up quite a bit to get to $290. So investment B definitely grew more. And we could figure that out exactly by saying 290.07 minus 260.55. And you could do that math and say exactly how much in dollars we increased. Lastly, in which quarter did investment B grow the most? Well, if we look, we grew about 14 from here. And then, unfortunately, we went down about $6 here. And then we went up a huge jump right here for about $22. Okay, so from quarter 3 to quarter 4, we definitely grew the most. All right, I hope this was helpful for homework and for studying.